Just to recap, Canada at the time needed something to fly in the Arctic, fly basically anywhere, without needing the assistance of the ground radar. It also had to get up to 50,000 feet in a limited amount of time to intercept bombers, which it easily done. It climbed as fast with a full payload as the CF-18 was climbing. I don't know about now, but it slightly outclimbed the CF-18 at empty weight. But this was a very powerful airplane. 60,000 pounds of combined thrust. On an airplane that weighed about 43,000 pounds. So we'll say 60,000 pounds fully loaded. Power to weight basically 1-to-1. Which even to today's standard, that's F-15 territory right there. Now, considering the engines were, even though they were reliable, the Iroquois engines were reliable, we ended up using the Arenda engines. The Arenda is the Iroquois, sorry. Let me think here. It's been a while since but anyway, the engines, we used the American engines in it first. And then the idea was to get our own engines in it. And they produced a lot of power. The full potential, because again, it never really had a chance to fine-tune the engines to get this thing up to the speeds that it was really designed to do. The goal was just to hit Mach 2. That was it. Because really at the time, there weren't too many fighters that could hit Mach 2. 1.9, 1.8, 1.7. But nothing really went to Mach 2. A handful of them, that was about it. But the idea was to do Mach 2 for, get yourself to where you need to be, cruise as fast as you could to get there, intercept, come back, short range interception. So that this thing was in interceptor mode on the 2,900 gallons of internal fuel. That would have lasted about 300-400 miles. That's it. But it was a hell of a 300-400 miles. It was designed to intercept, and that would have been the guys in the Arctic. Now the guys on the mainland, they probably would have had a drop tank and to get a little more range, throttle back a bit, and do more patrol. It would have been multi-rolled. It really would have. It would have been a good patrol airplane. Why? Because it was all weather, and again, it'd be able to fly outside the confines of the ground radar to be able to find targets. Now, in a dogfight, if this thing were to meet a MiG-15 or a MiG-17. In a dogfight, I would actually put my money on the MiG-15 or the MiG-17 just because of the maneuverability. However, above 35,000 feet, if this had a gun, and the pilot was really competent with it, the reason why I say that is it's not because the airplane, like airframe-wise, the airplane would have flown circles around those other airplanes. It's the visibility, and I can contest to the visibility because I've sat in the cockpit. I can tell you the visibility, this was not a dogfighter. Sitting in the cockpit looking straight forward, you can't even see the ground. It was hard enough to see the back of the museum wall sitting in this thing. And you definitely had no peripheral vision hardly at all on this thing. They were big enough, but it's like sitting at the back of a bus. That's the best analogy I can give you. It's that kind of a visibility. Even the P-47 probably had better visibility. But it wasn't designed for tight turning dogfight. It was designed to shoot down some bombers, and it needed that cockpit design, windscreen design, in order to achieve the speeds. That's where they had to reduce some of the drag, and that's why the nose, the cockpit looks like it does. Very Buck Rogers airplane, as they refer to it as. So we got a good idea of what this thing was designed to do. It was a truly multi-rolled airplane, but it was really specializing in interception. So what do we need now? Well, there's really not that much difference that we need. Again, when Canada builds things, we overbuild it and we make it 10 times bigger. Like if Canada made a stereo, it'd be made out of birch bark and weigh 200 pounds, you know what I mean? But it would last forever. It's just the way Canadians, give you an idea, especially if you're American, you're probably going to appreciate this. One of the most notorious, and probably still to this day, one of the best designed battle rifles of all time with the M1 Garand. Guess what? It was a Canadian who designed that. Everything about it is practical, and that's the way Canadians typically design things. Keep it simple, make it work. Now, I don't know what the maintenance schedule was on this thing, but considering how the first flight went, I would assume it wasn't that bad. It probably, you don't know until the thing's been actually put into service, like the F-16, for example. When it got put into service, I mean, it passed all of its trials, no problem, and it was a phenomenal airplane. It still is. But when they start going into service, next thing all these F-16s are crashing. Pilots are flying inverted. Next thing you know, for some reason, they keep ending up nosediving in the ground. At first, people thought pilots were just committing suicide. But what they learned, it was actually a wire would get pinched on the gyro, and considering the airplane was pretty much dedicated fly-by-wire, it would confuse the controls, and you'd think you're trying to pull up and roll over and pull up. Meanwhile, it thinks you're already rolled over and trying to push you down. And the F-16s were crashing. They nearly didn't make it into service, or they nearly got pulled from service. Sorry, a lot of people don't know that. But again, it's kind of one of those things. You could test something forever. It's in the real world where you're going to find the Achilles heel. So this thing, I'm sure it would have had a lot of Achilles heels, a lot of bugs to work out in the long run. But it was a great start. Again, design, drawing board to flying production airplane. It did not have a prototype. The production airplanes were the prototypes, so to speak. So what does Canada need now? Well, we definitely need something that can navigate through the Arctic. The CF-18 is a great airplane. I think it just needs to be a little bit bigger. That's all. Okay, if you want to put square intakes just to kind of stealth it down, I think stealth technology is kind of obsolete now. Unless the thing's completely invisible and undetectable, you really need to go back to the tried and true, fighter wing. But the other problem is that we're always going to have a need for fighters. Jean Chrétien said, the tank, we don't need a tank on today's battlefield. We don't need tanks anymore. Next thing you know, we're in Afghanistan. Hey, we need a tank. Bring back the Leopard. Take them out of the museums. Yeah, most of our tanks are Leopard tanks are in the museums. Yeah. Now they got some pretty outstanding tanks now. It'll never leave. These traditional weapons will never leave the battlefield. Drones. Oh well, drones is the new thing. Yeah, until the Chinese bring out their secret weapon of jamming them, then what do you have? You have a kite. And when it runs out of fuel, well, you've got a, basically at that one you got the V1 rocket or V2 VSTOL buzz bomb there, like in World War II. Hey, what's its bombing target? Wherever it runs out of fuel. Yeah, I don't have faith in drones. They are good until, but it's a computer chip or computer program away from being taken down. And there's people that probably, I'm sure they already know how to jam the, what is a drone other than a really overly expensive RC remote control airplane? And we see what happens when somebody has the wrong radio signal and they cross radio signals. Well, it's just catastrophic failure for the remote control airplane. Just change the scale of that. Drones are just, think of the Matrix. You kill one drone, you kill them all. Well, the same idea. At that point, you need a man to jump into a cockpit, scramble the airplane, get up, and intercept whatever is coming in. So I think airplanes will change their role, but they won't change the need. So if we have to build it, then what do we need to build? Well, first off, the airframes. This aerospace industry, I want to slap most of these people in the face. Because what they're really trying to do is sell you the technology, not the airplane. They want to say, we can build this, 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 and this. If it was really about building an airplane and having the best thing with the lowest maintenance, you could build something like this. Give you an idea. F-16, for every 1 hour flown is about 3 to 4 hours of routine maintenance. Okay, that's not battle damage or anything. That's average. That's quite a bit. A P-51 Mustang had to rebuild the engine every 24 hours of flying time. Okay, that's you're going to have a lot of guys working on that. Let's get to the CF-18 or even the F-18 if for the Americans. For every 1 hour flown, on average, is about 12 hours of maintenance. This is on an airplane that's fairly new. Our newest airplane, our newest CF-18, okay, was last delivered in 1987. Just so you know. So yeah, we do. That's why when Cold Lake, Alberta, you'll hear the odd, part fly off a CF-18. That's why it's the airplanes are, vehicles wear out. You know what I mean? That truck is an excellent truck, but it wore out. You just the mileage is high on it. So should we just build them again? Well, no, because the technology is a little bit outdated. Now, what have they done with the CF-18? Well, they've bumped up the engines, but again, it's a smaller airplane. It it needs to be the size of the Su-27. Why? Because of what we need. In fact, the Su-27 platforms, now the Su-35-Su-37, they're the same airplane. The prototype was known as Su-37. The in-service model is the Su-35. The Su-35 is probably the closest thing to what Canada needs. It really does resemble this in a lot of ways. Much more advanced, yes. Their Pac FA-50, their stealth, waste of money. Waste of money. Su-30, Su-37, that's what Canada needs for the most part. But not exactly. We need that robustness. We need something big like that because it needs to have long range. Su-27, 2,700 mile range. Now, it's probably mostly in ferry mode, I get that. Internally, it might be about 1,200 or whatever. Su-35, ferry range, I think, is like 1,800 miles. That's still pretty good. How big is Canada? Well, we need an airplane that can take off in Ottawa or Newfoundland, okay, and land in BC. That's what we need. We need a 3,000 to 4,000 mile range airplane. So, efficiency needs to be there. We also need something to intercept. Well, the F-35, I mean, hey, again, you have 60 degrees of super maneuverability. You don't have the same response as the lighter fighters, say, like the Mirage 2000. That thing will, like, you know, the snappiness of it is much more maneuverable than the F-35, you know, or the Su-35. But it doesn't have the weapons load. I mean, you know, you're looking at max takeoff weight, you know, on the Su-27, all the you know, even the Su-34, which is, you know, I think that would be a great patrol airplane for Canada. I'd add a little bit more wing area because it is kind of a ground attack strike bomber. It's not quite as fast as the Su-35, but it has a long range and very fast cruising. So it would be good for, you know, you could do a patrol the country in 3 or 4 hours, you know, if you have the fuel. And Canada, you know, we should have enough fuel here considering the, you know, just have to, you know, get the bitumen productivity up, you know what I'm saying? So when you have that, these airplanes actually, they carry, you know, they carry 20,000 pounds of payload. That could be fuel or bombs, and about 8,000 pounds to 12,000 pounds of ordnance is the max. You know, you have to ratio it out. You can only fit so much on the wings and the loading and stuff like that. So they can carry a lot. So I'm going to make this a 3-parter. Okay, so just to recap, Canada at the time needed something to fly in the Arctic, fly basically anywhere, without needing the assistance of the ground radar. It also had to get up to 50,000 feet in a limited amount of time to intercept bombers, which it could easily done. It climbed as fast with a full payload as the CF-18 was climbing. I don't know about now, but it slightly outclimbed the CF-18 at empty weight. I mean, but this was a very powerful airplane. You know, 60,000 pounds of combined thrust. You know, on an airplane that weighed about 43,000 pounds. So we'll say 60,000 pounds fully loaded. Power to weight basically 1-to-1. You know, which even to today's standard, that's F-15 territory right there. Now, considering the engines were, even though they were reliable, the Iroquois engines were reliable, we ended up using the Orenda engines. The Orenda is the Iroquois, sorry. Let me think here. It's been a while since but anyway, the engines, we used the American engines in it first. And then the idea was to get our own engines in it. And they produced a lot of power. The full potential, because, I mean, again, it never really had a chance to fine-tune the engines to get this thing up to the speeds that it was really designed to do. The goal was just to hit Mach 2. That was it. Because really, at the time, there weren't too many fighters that could hit Mach 2. 1.9, 1.8, 1.7. But nothing really went to Mach 2. A handful of them, that was about it. But the idea was to do Mach 2 for, you know, get yourself to where you need to be, cruise as fast as you could